The following has been developed by state and provincial agencies in association with the Agency for Instructional Technology. Together, serving education.
Smartest kid in the class. I'll split everything, 50-50.
Hey, slow down. What's this all about?
Well, have you heard of Mr. Washburn? You know, that rich old man that died last week. Well, I used to run errands for him, and I guess he liked me, so he left me this letter.
Dear Tim, I want you to love patterns as much as I do. So if you can solve all the patterns here, it will lead you to the key to the safe behind the picture of my wife in my study. You can keep the treasure you find inside. Wow!
So will you help me?
Sure, but I don't understand. Why patterns?
Because Mr. Washburn's company sold tiles. You know, like the kind people have in their kitchens. He loved the patterns they made. He loved all kinds of patterns.
If Tim and Jenny are going to find the key, they'll have to understand a lot about patterns. Exactly what makes something a pattern? Well, a pattern is a sequence of shapes or numbers that can be predicted in an orderly way. Here's one kind of pattern made up of colors and shapes. Here's a similar kind of pattern. Some patterns are based on geometric figures, and other patterns are made up of numbers. Often it's easy to see a pattern, but sometimes you have to do some work to find it.
The letter says to start in the study.
Hey, wait up! That must be the study. Watch out!
Okay, first problem. We're supposed to find the next number in this number sequence.
What's the sequence?
1, 5, 9, 13, 17.
Let's see. The numbers go up each time, but by how much? 1 and 4 more are 5, and 4 more are 9. Okay, the next number has to be 21.
To get the answer, Jenny used a method called guess and check. She noticed that the difference between the first two numbers was 4 and guessed that the numbers might go up by 4 each time. To make sure she was right, she checked it out. In this case, just as Jenny said, it always comes out 4. So she added 4 to 17 and came up with the missing number in the sequence. In guess and check, you look for a pattern, guess what it might be, and then check to see if your guess holds true for the other numbers. If it does, you simply carry out the pattern to solve the problem.
20, 21. If you have solved the pattern correctly, there will be a door directly on your right.
There is a door.
Now find the next number in this number sequence.
What's the sequence?
1, 2, 2, 4.
Here's the new sequence. Do you see any pattern? Well, at first there doesn't seem to be one. The numbers seem to get larger and smaller in a random fashion. But if you look at every other number, you can see they appear to get larger in a regular way. 1, 2, 3, and 2, 4, 6.
Hey, I think I know how to figure this out.
What are you doing?
I'm breaking up the numbers into 2 columns. The first number goes in column 1. The second number goes in column 2. The third number goes in column 1, and so on.
Hey, I can see the pattern now. In the first column, they go up by 1. In the second column, they go up by 2.
Right, so you can see what the next number must be.
It's got to be 12.
12 it is.
So now I'm supposed to open the door and take that many steps.
Oh, it's dark down here. Are you sure he was a nice guy?
Just give me the flashlight, okay? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm at the bottom.
I hope we don't have to stay down here long.
You should now see a coat rack.
Over there!
After you solve the next problem, place your back to the coat rack and proceed that many steps.
Here's what Jenny and Tim have to solve. How many H's should there be in the H column of this figure? Well, we can see the letters progress alphabetically, A, B, C, and so on. And each column is longer than the one before. But is there a pattern here? How can we tell?
I'm going to write the numbers of letters above each column. 1, 3, 5, 7, 9.
Hey, I see the pattern. They go up by 2 each time.
H is the 8th column.
So the number must be 15. 4, 5, 6. Oh no, the light went out.
Keep going, Tim, don't stop.
Leonardo Fibonacci was a European mathematician who lived about the year 1200. He contributed a great deal to mathematics in the areas of algebra and geometry. Today, when we hear the name Fibonacci, we think of a sequence of numbers named the Fibonacci sequence. Here we have the first numbers of the Fibonacci sequence. The numbers are developed in a pattern. Can you tell by the pattern what number comes next? If you don't see the pattern, perhaps looking at the last 3 digits, 3, 5, 8, would be a clue. If you see the pattern, you'll notice that each number in the Fibonacci sequence is the sum of the 2 preceding numbers. 2 is the sum of 1 and 1. 3 is the sum of 1 and 2. So the next number in the sequence is the sum of 5 and 8, or 13. We can also find these kinds of number sequences in nature around us. Here is a pine cone. We find that the scales grow in rows, and the number of rows of scales are numbers in the Fibonacci sequence.
We're supposed to go to the bench and aim for the sundial. Over there.
Uh-oh, this looks tough. If there are 9 soldiers on each side of the pentagon, how many soldiers are there altogether?
Gee, how are we going to figure this one out?
I think we better make a table.
Jenny's smart. Some people would have tried to draw all the soldiers and then count them. But what if there were 9,000 instead of 9? How would you get the answer then? Jenny's idea of making a table is an excellent way to figure out a pattern. But how should she go about it?
In the first row, I'm going to write the numbers of soldiers on each side. In the second row, I'm going to write the total number of soldiers. Get it?
Sure. Let's see. The first pentagon has 2 soldiers on each side, 5 total.
Once you've filled in your table with the information you have, you can start looking for a pattern. Do you see one? Each time there's one more soldier on a side, the total goes up by 5. We could keep filling out this table endlessly, but do you see any other way to get the answer to their problem?
Look, Tim. To get the total number, all you have to do is multiply 5 times the number before it. See, 5 times 2 is 10, and 5 times 3 is 15.
So if there are 9 soldiers on each side, all you have to do is multiply 8 times 5, right? So the answer must be 40. 38, 39, 40. Okay, this is the last one. We're supposed to solve this problem and take that many steps to the fountain.
Gee, it looks like he saved the toughest for last. I think we better make a diagram.
The problem is this. Grandma just started making this quilt. It will be 7 squares across and 14 squares long. How many squares of yellow will Grandma use? Well, Jenny is right. Making a diagram will help. It's one of the best ways to work with a geometric problem like this. First, let's see if the colors repeat themselves in an orderly way. Looking across, we see blue, followed by red, followed by yellow. And looking down, we see the same order repeated. Now that we know our color pattern, we can make our diagram.
Why are you only doing the first 4 rows?
Because you can see that the pattern repeats itself every 3 rows, so you don't have to do the rest. There are 2 yellow squares in the first and second row, and there are 3 yellow squares in the third row. We add them up and get 7.
So you can see that there are 7 yellow squares for every 3 rows, right?
Right.
Using this diagram, can you figure out how many yellow squares Grandma will need for 14 rows? All you have to know is how many sets of 3 rows there are in 14. There are 4 full sets and 2 extra rows. If there are 7 squares in a set, there are 28 yellow squares plus 2 plus 2, or 4 more. So, Grandma needs 32 squares of yellow.
27, 28, 29, 30, 31, 32? The key should be right there. Whoa! Key!
Let's go.
The key fits. It's turning.
What's inside?
Oh no! A book! There's a note inside. Dear Tim, congratulations. This book of patterns is the real treasure. However, there's something else you might like under the ink blotter on my desk. Yeah, probably another pattern. Stop certificates?
Stop certificates, we're rich!
MathWorks is a component of the Mathematics for the 80s project and is supported in part by Exxon Education Foundation. This program is produced by the South Carolina Educational Television Network under the supervision of the Agency for Instructional Technology.